Children, today we learn about LCM, least common multiple. Least common multiple. Okay. So we call this as LCM. So we take some common multiples. In those common multiples, we take the least one, that is least common multiple. For example, I am taking two numbers, 2, 3. Two numbers I am taking. What is the LCM of 2, 3 means? What is the LCM of 2, 3 means? Something we will write. See. So first I am taking 6, some 18, 24, etc. Something I am taking. Okay. So 6 is the multiple of 2 and also 3. 18 is also multiple of 2 and also 3. 24 is the multiple of 2 and also 3. If I take something if I take 48. 48 is the multiple of 2 and also 48 is the multiple of 3, etc. So these are all the multiples of 2, 3. In all these multiples, what is the least one? 6. So LCM of 2, 3 is 6. That is the meaning. LCM is. This is the meaning. Okay. So coming to one more thing. I am taking two numbers, that is 15 and 24. Two numbers I am taking. What is the LCM of these two means? Do the short division. This is also shortcut, short division. So 3 is the multiple, 3 is the factor of 15 and also 24. So any number common factor, any common factor is there for both the numbers. First we will check. So yes, it's there, that is 3. 3 5s are, 3 8s are. So for these two numbers, any common factor? No. So we leave the division here. So we take the product of 3, 5 and 8. Now 3 into 5 into 8 equal to 3 5s are 15, 15 8s are 120. So LCM of 15, 24. LCM of 15, 24 is what? 120. This is 120. Okay. We take some more numbers. That is, we take C. Now I am taking 3, 9, 10. 3 numbers I am taking. What is the LCM of 3, 9, 10? Here also we do the short division. So first we will check in all the 3 numbers. In all these 3 numbers, any common factor is there for all the 3 numbers. Means for all the 3 we don't have any common factor. But for these 2 numbers we have a common factor, that is 3. So if we are not having any common factor of all the 3, next we go to the next step, that is any common factor is there for the 2 numbers, in that way. So first 3. 3 1s are, 3 3s are. For 3 is not going in 10, because of that just take it as it is. 10. As it is. So for 3 and 10, any common factor is there? No. Now LCM of 3, 9, 10 equal to, so we take the product of these numbers. 3 into 3 into 10. 3 3s are 9, 9 10s are 90. This is the LCM. This is the LCM. Okay. One more bit we'll see. One more bit we'll see. That is, now I am taking 25, 40 and 100. 3 numbers I am taking. So here also we see the same short division, shortcut. So 25, 40 and 100, all the 3 numbers are the multiples of 5, means 5 is the common factor of all the 3 numbers. So 5 with 5. 5 5s are, 5 8s are, 5 2s are, 5 20s are, 0. Okay. So again 5, 8, 20. For all these three numbers, any common factor is there? No. But for these two numbers, 8 and 20, common factor is there. That is what? 2. That is what? 2. So with 2. So 2 is not going in 5, as it is, you take it the number 5. Now 2 4s are, 2 10s are. Again for 4 and 10 common factor is there. Or 5 and 10 also common factor is there. So you can take these two or these two. No problem. Any two you can take, because all the three numbers are not having the common factor. So because of the any two you can take. You can take 5 and 10 or you can take 4 and 10. Now okay, now I am taking 5 and 10. So 5 is the factor. 5 1s are. 5 is not going in 4. So as it is, you take 5 2s are. Okay, 5 2s are. Now in 4 and 2, so 2 is the common factor. Now 2. So 1 as it is, 2 2s are, 2 1s are. Now what is the LCM of 25, 40, 100 means you should take the product of all these numbers. So LCM of 25, 40 and 100 equal to 5 into 2 into 5 into 2 into 2. No need to write 1. No need to write 1. 5 2s are 10. 10 5s are 50. 50 2s are 100. 100 2s are 200. So 200 is the LCM of what? 25, 40 and 100. 25, 40 and 100. So one more method is there. This is the shortcut method or short division method. One more method is there. What is that? Let me explain. That is to find out LCM. So that is prime factorization method. Prime factorization method. So means you use only the prime numbers. That's all. So now I take the same example, 25, 40, 100. What are the prime factors of 25? Means 5 5s are 25. Okay. Next 40. No more factors. 5 is prime, 5 is prime. Okay. 40. For 40, first 2 20s are. Okay. Next 2 into, again for this 20, 2 10s are. Again 2 into, for this 10, again 2 5s are. So 2 is prime and 5 is also prime. This is the product of primes. This is also product of primes. Next 100 I am taking. First with 2 50s are. Next 2 into, again for 50, 2 25s. All prime numbers you should take. Next 2 into, for 25, 5 into 5. All are prime numbers. Now you see, here 5 into 5 is there. Here 2 into 5. Here 2 into 5 into 5. Okay. Now first we will check the common factors of all the three numbers. 5 is there, 5 is there, 5 is there. So LCM is equal to, first we will write 1 5 because this is common. Okay. Next common factors we will check. Here 5 is there, here 5 is there. Okay. So in three numbers we don't have 5 common factor. Here we have 2 numbers. This is 5 into 5. So one more. So only these two are having 5. So I took. Next 2's. Here 2 is there, here 2 is there. I am taking 1 2. Next here 2 is there, here 2 is there. I am taking next 2. So 1 more 2, 2. So this is the way. Okay, so all the 3 are having common factor, we'll take only one, that common factor will take. Okay, next only 2 numbers are having common factor, that also we take 1. Next 2 numbers are having one pair of 2, that we took. Next these 2 numbers are having another pair of 2 and 2. This is the remaining one, that remaining one also will take. Common factors are there, we take only one number, and remaining number is that also we will take. Now we take the product. 5 5s are 25, 25 2s are 50, 50 2s are 100, 100 2s are 200. This is the way of doing prime factorization method. But compared these two, this is the easiest one, because this is a short division. So this is the easiest one. Whatever is easy to you, that you can follow. So how to find out the LCM means, this is the way of finding LCM. LCM is least common multiple. What all the multiples we have, in that multiple we take the smallest one. So that is the meaning of LCM. LCM. So now we will see, already I said in the previous class, what are rational numbers and what are irrational numbers. Already I said in the previous class. Once again I'll explain. What are rational numbers? Rational numbers. And what are irrational numbers? Irrational numbers. Listen properly. Okay. Very easy. Rational numbers means we denote those as Q. They are in the form of P by Q. Rational numbers are nothing but fractions. So all natural numbers are rational numbers, because natural numbers, whole numbers, integers, these are all the subsets of rational numbers. Because of that, any rational number we can write in the form of P by Q, where P comma Q belongs to integer set and Q, the denominator, not equal to 0. This is the rule. Okay. In rational numbers, fractions are there, and also terminating decimals also rational numbers, belongs to Q. And also one more thing, terminating decimals and recurring decimals also rational numbers. The rational numbers are nothing but fractions, and also terminating decimals are rational numbers, recurring decimals are rational numbers. How we will see? Terminating. Okay, a number, a decimal is terminating with 2 digits. Let me say, okay, 1.25. This is a terminating decimal. First example, 1.25. It terminates with the 5. It terminates at the 5. Okay, means 1.25 is the terminating decimal. So we can write this as 125 by 1 followed. How many decimal points are there? 2 decimal points. 1, 2. So we take 2 zeros. So after the cancellation, 25 5s are 25 4s are 5 by 4. This is a rational number. Means any terminating decimal is a rational number. Okay, one more decimal. Okay, I am taking. Here I am taking 1.3. Means 13 by, how many decimals are there? 1 decimal. So 1 followed 1 0. So 13 by 10. Any cancellations are there? No. So 13 by 10 is the rational number. Belongs to Q. Okay. Coming to recurring decimal means, one more example I am taking. Recurring means I am taking 1.2 dot, or in some textbooks 1.2 bar, whatever it is. So dot or bar denotes this number is recurring, means 1.2 dot means 2, 2, 2, 2, 2. You don't know. Infinite times. That infinite number you don't know. Means 1.2 dot means 1.22222 we are writing. Okay. So this recurring decimal, how it belongs to rational number set means, see how to solve this problem and see. 1.2 means 1.2222. So first let x equal to 1.222 etc. Okay, this is let x equal to, how many decimals are there here? Only one decimal, so 10x. Now 10x equal to 10 into 1.222 etc. So if you multiply, this decimal is coming to the front part, 2 12 point, again 22222 etc. Okay, so x is this, 10x is this. Now subtract 10x minus x, so you will get 12.222 etc. minus 1.222 etc. means check, see the problem, means you will get like this, 10x is 12.222 etc. your x is 1.222 etc. Now what are you doing? You are subtracting, doing subtraction, means 9x equal to, these decimals will be cancelled. Now 12 minus 1 is how much? 11. Now x equal to 11 by 9. So belongs to Q. This is the rational number. So 11 by 9 is the rational number. It is in the form of P by Q, and Q not equal to 0. So any terminating decimal you can convert into a rational number. So here this recurring digit is only one digit. Sometimes you get 2 recurring digits, sometimes 3 recurring, sometimes 4 recurring. Depends on the problem. Depends on the given decimal recurring number. So we do the problem, we solve the problem. Okay, so this is the way of doing. So what are irrational numbers? Irrational numbers means a number which is not rational, that is irrational. A number which is not rational, that is irrational. Means square root of any number which is not a perfect square. Square root of any number you take which is not a perfect square, that is an irrational number. So root 2, root 3, root 6. Okay, root 3 plus 2 means any irrational number and this irrational number and an integer, if you add, the whole result will be irrational. Or 3 minus root 5, so the whole result is irrational. Pi is also irrational. So means square root of any number which is not a perfect square, that is irrational. And also what are the irrational means? So any number, any decimal number which is not terminating, any decimal which will not terminate means a value like this, 1.734 0312 and 7056 next 098 and 192 2 in this way. It is going, but it won't terminate. Such numbers are also called irrational numbers. So irrational numbers means any square root number and which is not perfect square, and also if you add any integer or any irrational number to the irrational number, the whole value will be irrational. Pi is irrational, and any decimal number which will not terminate. So this is also irrational number. Okay, these are all irrational numbers and these are all rational numbers. One more example I will explain. See, one more example I will see. So madam, you explained a recurring decimal of one digit, but we want to know a recurring decimal of 1 point, now 3 digits, 3 recurrings I am taking, 3, 5, 2. All the 3 are recurring. Means if you take x, the number will become like this: 3, 5, 2, again 3, 5, 2, again 3, 5, 2. Oh, go on. Understand? So this is the number we will get. Means recurring. 3, 5, 2 are recurring. So here how many decimals are recurring? Means 3. Means 1 followed 3 zeros. 1000x. E means 1000 into x. 1.352, 352, 352, etc. If you multiply 1000 and x, the first 3 decimal, so coming to the left part, means 1352 dot, means you are multiplying. So for 3 zeros, the 3 decimal part will be cancelled. So 1352 dot, again 352, 352, 352, etc. Okay, so this is what? 1000x, and this is x. What is your x? X is only 1.352, 352. Please don't write your 1 in this place. 1 is ones place. See here ones, tens, hundreds, thousands. You should write 1 in ones place. So 352, etc. Now what are we doing? Subtraction. So 1000x minus x, 999x. So here 2 minus 1 is 1, 5, 3, 1, and rest of the thing is cancelled. Subtraction. So what is your x? X equal to 1351 by 999. If any cancellations are there, we'll cancel. Otherwise, this is your what? Rational number. So any recurring decimal, you will have 4 decimals recurring, or 2 decimals recurring, or 5 decimals recurring. It depends. If 4 decimals are recurring, so you write 1 followed 4 zeros. 5 decimals are recurring, you write 1 followed 5 zeros. Then you subtract. You will get the answer. This is the way of doing a recurrent decimal into fractional form. Okay, fractional form. So next is next I want to explain. See, some problems are given. So A and B and C, 3 bits are given. So whether they are rational or irrational, that you will say. So first is 1.3, second is minus 2, 3 by 5, and C bit is cubed root of 8, and D bit is root 7, and E bit is 0.11 dot dot. Okay, 1 dot 1 dot. So 0.1 dot 1 dot. So 1.3, easily we can write 13/10. So this is rational. This is what? Rational, belongs to Q. So here minus 2 3/5 means which equal to 5 2s are 10. 10 plus 3 how much? 13. Minus 13/5. This is rational. This is rational. So here cubed root of 8 means cubed root of 8 means 2 cube. 2 2s are 4, 4 2s are 8. 2 cube means 2 cube. Cubed root of means 1/3 whole to the power of 1/3. 2 cube whole to the power of 1/3. 3 and 3 gets cancelled. You get 2. Belongs to Q. Root 7. Root 7 means 7 is not a perfect square. So this is irrational. Means belongs to Q bar. Irrational. This is a recurring decimal. So this is Q. This belongs to Q. This belongs to Q. Some more bits are there. Whether they are rational or not. That also we will see. Whether they are rational or not. That also we'll see. So one more bit. That is root 2 into root 3. This is irrational. This is irrational. Product of two irrationals is root a into root b equal to root ab. Means root 2 into 3. That is root 6. Irrational Q bar. Okay. Next. Root 2 plus root 3. This is irrational. This is irrational. Addition of two irrationals is irrational. So belongs to Q bar. And more bit. See. 2 root 5 by 2 root 20. 2 gets cancelled. Root 5 by root 20 we can write as root of 4 into 5. So this is equal to root 5 by root a into root b equal to root a into root b. Yes. So root 5 gets cancelled. 1 by root 4 is 2. So this is what? Rational number. This is what? Rational number. So in this way we will do the problems. One more bit I am taking. See whether it is rational or irrational. 4 plus root 9 minus 4. This is the problem. So 4 plus root 9 means what? 3 minus 4. So 4 plus 3 minus 4 how much? Minus 1. So plus into minus is minus. 4 minus 1 which equal to what? 3. This is rational. This is what? Rational. This is the way of doing the problems. Sometimes they ask some questions whether it is rational or irrational. So you should do the small calculation. After doing that, sometimes by seeing directly we can say it is rational or not. But sometimes we do the small calculation afterwards. We can say whether it is rational or irrational. Thank you for today. Tomorrow I'll continue.